So we're being asked to factor by grouping and using our area model. The very first thing you need to do is you need to make sure you're in standard form. Standard form meant the highest exponent went first. My highest exponent is not going first, so I need to rewrite it. So this is a positive 18v to the third, so positive 18v to the third. Exponent 3, which means now exponent 2 comes next, so that's a negative 48v squared. So there's my minus 48v squared. 3, 2, now I need the exponent of a 1, so here is 63v. 3, 2, 1, now I need the exponent of 0, which meant there was no variable. So there I am in standard form. Now I need to find the GCF. There are 4 terms, which meant I need 4 lists. And these numbers get a little large, so over like on a scratch piece of paper, I would do factor trees for some of these to be able to figure out your prime factorizations. 18v to the third is 2 times 3 times 3, and there were 3 v's because it was v to the third. The only way to have a negative is to have a negative 1. 48 is 6 times 8, but neither are prime, so I have to prime them. So here is my 8, and then 2 and a 3 for my 6, and v squared is v times v. 63 is 9 times 7. 9 is not prime, so I need to prime the 9. So here is my 9. And then here is my 7, and it had a v on it. The only way to have a negative is to have a negative 1. 168 is the thing I would have had to do my prime factorization tree on. And if you did the prime tree, you would have found 2 times 2 times 2, which is 8, times 3 times 7. So 8 times 21 would have given you this, and then you have to factor it all out. So now that I have all 4 of my lists, I need to do my GCF. So looking at it, they do not all have 2s, so that doesn't work. I see that they all have at least 1 3. They do not all have a second 3. They do not all have v's or 7s. So 3 looks like it's going to be our GCF. So my GCF is a 3, which means when I rewrite it out here, here is my GCF. I am now in a parenthesis going to list all of the 4 parts that are left over. 4 lists, 4 chunks. So 2 times 3 is 6, so this is 6v to the third. Negative 1 times 2 times 2 times 2 times 2. So this is a negative 16, and that had a v squared in it. 3 times 7 is 21, so that's a positive 21v. Negative 1 times 2 times 2 times 2 times 8, so this is a negative 56, and there were no v's in it. So the next step is to do the area model. You're going to do the area model of this leftover parenthesis information. So here is my area model. You start at the very front, and you're going to walk your way through and walk your way through. So negative 16v squared, 21v, and a negative 56. You need to just find 1. I like finding the 1 in the first top row. So 6 and negative 16, the largest number they have in common is 2. V to the third and v squared, the number of v's they have in common is v squared. So once I find 1, everything else is just a multiplication game. So 2 times 3v. So 2 times 3 is 6. V squared times v is v to the third. 2 times a negative 8 is going to give me this negative 16. It already had a v squared in it, so no more v's. Negative 8 times 7 is going to give me this negative 56. And double check, does 7 times 3v give me positive 21v? It does. So my final step is to give me my final answer. You have to write the GCF part first, and then your 2 parentheses are going to come from the sides. So this parenthesis is going to go here, and this side is going to come here. So this is 2v squared with a positive 7. So 2v squared with a positive 7 plus 7. 3v with a negative 8. So 3v minus 8. This is your final answer, and you're done. So we're being asked to factor by grouping using the area model. The very first thing you need to do is you need to check to make sure it's in standard form. The highest exponent is supposed to go first. So this says 5, 4, 3, 2. So the highest exponent is first, and they do go in descending order, which tells me that I am in standard form. So step 1 is done. I need to see if there is a GCF in any of this. So if there are 4 parts, that means I need 4 lists. And then I am going to end up using a prime factorization tree to figure out what my lists are. So 63 is 9 times 7, but 9 is not prime, so you had to break the 9 up. And n to the 5th meant there were 5 of them, so make sure there are 5 of them. 54 n to the 4th is going to be 6 times 9. Neither are prime, so you have to break both of them up again. N to the 4th meant there were 4 of them. Negative, the only number allowed to be negative is -1, so -1 has to be there. 105 is actually 15 times 7, and 15 is not prime, so you need to break the 15 up. So there is my 15 times 7. N to the 3rd meant there were 3 of them. The only number allowed to be negative is 1, and then 90 is going to be 3 times 30. So 2 times 3 times 3 times 5 would end up being that. And then n squared is n times n. So now I am going to look for a GCF. I'm looking to see what they have in common. First thing that I actually see is all of them actually have 2 n's in common. So I know for a fact that I have 2 n's in my GCF, but now I need to double check numbers. Looking at my numbers, I see they have at least 1 3 in each list. I do not see any other 3's because this one doesn't have any more 3's. No other numbers and no other letters. So I have 3 times n, which gives me a 3n squared. So 3n squared is my GCF. So when I come over here to rewrite it, you need to write 3n squared saying, hey, this is what I'm pulling out at the very, very beginning. And now you need to tell me what is left behind in my lists. So this is 21n to the 3rd. This would have been 9n squared. Sorry, that is 9. 9 times 2 is 18. So that's 18n squared. This is a negative 35n. And this is a negative 30. So next step is area model. And you're area modeling whatever is left behind in this parenthesis. So here's my area model. Start at the very beginning. Oops, that's a 21n to the 3rd. And then you're going to walk your way through, and we're going to just walk our way through. So now we just need to find one GCF, the one across the top. So 21 and 18, the largest number they have in common is 3. N to the 3rd and n, the largest they have in common is n squared. The minute you find one of the sides, everybody else is just a multiplication game. So 3 times a 7 would have given me the 21. N squared times n would have given me an n to the 3rd. 3 times 6 would have given me the 18. N squared times just the 1 is an n squared, so this is correct. 6 times I need it to be a negative 5, because 6 times a negative 5 would give me a negative 30. Negative 5 times 7 is a negative 35, and its n is already there. So we finished. Last step is to give me my final answer. You cannot forget this GCF. We had a GCF taken out at the very, very beginning. And then what is in the 2 parentheses are your sides. So this side goes into this parenthesis, and this side goes into this parenthesis. So 3n squared minus 5, and 7n plus 6. And this is our final answer, and we're done.